Hello, and welcome to the latest installment in our UXDX online series. I hope you're as excited as I am for the talks we have this evening. But before we jump into those, I want to give a really quick introduction to UXDX and why we host these sessions. So at UXDX, we always say the world is full of bad software. And what I mean by that, it's not software that doesn't do what it's supposed to do. But I use the example of banking. And I've got one of those brand new digital first banks, as well as some traditional banks. And while the apps technically do the same thing, they're worlds apart in terms of the user friendliness and usability of them. And I know which one, because of that I reach for. So at UXDX, our mission is to help companies build an environment that can't build bad software. Because I don't think it's down to skills. I don't think it's down to the motivation of people. I think it's the environment that they're working in and the constraints that they have that forces them down these paths. Now, how we advocate for that is to shift away from projects or water scrum fall that a lot of people follow, to truly empowered autonomous teams that can talk to the customers, learn from them, and then iterate on the ideas that they come up with. And that's really easy to say and really hard to do in practice. And that's where the talks come in. So nobody is going to share how they're changing their ways of working, but what they're going to say is how they're changing parts of that whole entire kind of process. And they'll be sharing how they're improving what they're doing and the benefits of that. So hopefully while you're listening, you might come up with some questions on how you can apply that to your context. So please do write those questions in on whichever platform you're watching this on. And we'll have time at the end of each talk to ask those questions to the speakers. So please share early and we'll make sure that we get those questions answered. That's enough about me. You're not here to listen to me speak. So I'd like to introduce our first speaker for this evening, who's Julian Burr, who's a software engineer at Askable. And Julian's going to be talking about server components, out-of-order streaming, and the future of the web. So I'd like to welcome Julian to the stage. Over to you.
Awesome. Thank you. Yes, I want to talk about the future of web development. And for that, I will basically touch on two major innovations that fairly recently kind of popped up into that whole space when it comes about web applications. The first one is suspense. So React introduced suspense a while ago. Other frameworks have caught up by now. They might call it something different. You might know it under a different name. But the idea of suspense on the client is basically to give us more control over loading states. So by giving us the ability to wrap certain parts of our application in what we call suspense boundaries, we can then show a loading state or like a fallback UI whenever anything within those boundaries is doing some asynchronous work. So that's usually fetching data, but it could be other asynchronous stuff like lazy loading JavaScript chunks or you name it. And the idea is that we then don't have to have very granular loading states of like having like a spinner in each of our components. And instead, we can be much more deliberate about which section of our application should have a loading state and what that should look like. So that's already great. The second thing that I want to talk about is server components. And to understand what problems server components are trying to solve, we kind of need to take a look at the history of web rendering first. And we need to go kind of all the way back to like the good old days, plain HTML, and PHP. It could be any other server-side language. The idea is plain HTML was great because it was literally just serving files from the server. That's really fast, but it's very static. So in order to be able to serve dynamic content, we started introducing those server-side languages like PHP. And the benefit of that is we can serve stuff that is connecting to a database or other outside sources. But the downside of it is if the more work we actually do on the server, the slower the server response time gets. And especially at scale, that can become very noticeable very quickly. And at those times, that was not only a problem for the initial load, but also every subsequent node. So if you navigate around the application, we would need to do a server request for every of those navigations. And if those server requests take a long time, that's not a great user experience. So we started to introduce JavaScript into the whole thing. This is the jQuery era, like 2006-ish, and the early days of Ajax. So Google introduced that concept of being able to do server requests from the client after the page has already been loaded. And that's great because that gives us the ability to be much more explicit about what we're actually fetching from the server. So instead of having to fetch the whole page every time the user navigates, we can just fetch certain subparts of the page that we know change, and we can keep like the main navigation and stuff like that untouched. And because it's all happening in JavaScript on the client, we can also we're more control over what we actually want to do. When we swap out the content, we can maintain client-side state like scroll positions, etc. So this is generally great. Like, it definitely improved the user experience. The developer experience was pretty lacking at the time. It was mixing concerns of like, where does the HTML actually live? What do we do with JavaScript? We're mixing those two worlds. It's also famously the era of spaghetti code, because at the time, frameworks were pretty sparse. So like, people were usually running their own solutions and reinventing the wheel. So that wasn't great. And as a solution, we then just decided to, okay, let's just go all in and everything on the client. We tried to completely remove the server, and it's the era of single page applications. So this is the frameworks that you probably know of, like your Angular, your Vue, your React. And the idea was the server really just serves like an empty shell, like an empty div. And then we do all of the work in JavaScript. And that gives us full control over how we want to generate the DOM for the page and what we want to do with the DOM when certain events happen. And it allowed us to build much more dynamic applications, which is great. And the user experience after the initial load, when people navigate around and click around, also great. The big downside is the initial load. Because it's just sending an empty shell and then doing a lot of work in JavaScript, based on your device and based on your network speed, that initial load can become a real bottleneck. And we realized that fairly quickly. So we started moving back again by introducing concepts like server-side rendering and static site generation. So the idea of server-side rendering is to have a server that's still running, that gets the request, and it generates that initial HTML from your React app or whatever framework you're using, and sends that back additionally to the JavaScript bundle that then makes everything dynamic. So this is trying to get the best of both worlds. So we still have everything in our frameworks that we love, but we're now doing the server-side rendering to get that quick initial render, and then everything subsequent still gives you the single page application benefits from a user experience perspective. And this seems great, but it still comes with two problems. For one, we haven't dealt with the original problem of the HTML and PHP era yet. Like, if we do a lot of work on the server, that server response is still going to be slow. The second problem is a new problem that we kind of introduced, which is called hydration. Because everything is written in JavaScript and by default everything can be dynamic, we have to essentially render our app twice, because things like event listeners or local state don't exist on the server. We can only render a static representation of that on the server. And because we don't really know what's dynamic, we have to essentially on the client run a virtual copy of the whole app again, just to be able to then inject those dynamic parts. So that's a big downside of frameworks like React. And again, we realized that that became the main bottleneck. Enter server components. So this is one of the primary things server components are trying to solve. The idea of server components is that you can tell your bundler which of your components are static and which components are dynamic. Static components, by definition, just render HTML. They don't need any JavaScript. They can just be shipped as part of that HTML response. Nothing needs to be added to the JavaScript bundle. Dynamic components are components that have event listeners, local state, etc. So they do need to be sent to the client. But by being very explicit about it, and most importantly, by having server components be the default and you have to opt into client components, at least that's how React does it, we're basically going back to what we used to have with HTML, PHP, and maybe some jQuery sprinkled around. It's the static by default, dynamic as opt-in, and you're much more deliberate about what you're actually sending to the client. So this massively reduces JavaScript bundle sizes. It massively reduces that hydration problem that we saw. What it doesn't do is do anything about that first problem of like, if the server does a lot of work, that server response time still leads to a bad user experience. And this is where the combination of server components and suspense can actually be really magical by introducing a new concept of how we render our applications. And to understand that, we're actually going to build a very simplified version ourselves. So to do that, I'm basically going to try to compare 3 different ways historically how we've rendered web application. The first one I'm going to call the classical server-side rendering. So again, that has all of the problems that I just mentioned. When the server takes a long time, the server response is slow. We can improve that with streaming. Streaming has been around for forever, essentially. So we're going to take a look at that, and then we compare that to what we call out-of-order streaming. And this is what suspense in combination with server components allows us to do. All right, so let's write some code, hopefully. To do all that, I basically built a very small demo application to show the difference between the different approaches, not only in code. If you're not a developer or you don't know React or JavaScript very well, don't worry. The frameworks or implementation details are not really the core of this. The core that the main idea that I want to bring across is the concept that's more on a user experience level. So don't freak out when we switch to a code editor in a second. But this is the demo application. So it's a very simple movie app because that's what everyone seems to be building in their demos. We have our logo at the top, and we have a title section with a poster, the movie name, and some meta information. We have a detailed section with a movie cast, and at the bottom we have a footer section with similar movies, so I can keep clicking around in that infinite loop of binge watching. Like I said, there's not much to that app, and if we look at the code, it's an Express application, so a simple HTTP server. There's no fancy frameworks or anything on top of that. And then I basically exposed 3 different routes, and those are the different implementations that I just mentioned: the classical rendering, the streaming, and the out-of-order streaming using suspense. So let's take a look at the classical rendering. I'm using JSX here, and I'm using React to render that JSX to HTML. That's mostly for convenience and because it makes it easier to read. Again, the core point that I'm trying to make is the user experience that we're introducing. We could do all of that with just writing plain JavaScript HTML strings. So none of this is tied to any framework. This is really more a concept that you can apply to anything. But what we're rendering here is basically what we've just seen on the screen: the header, the title section with the poster and everything, details with the cast, and a similar movies section. And if we look into one of those components, you can again see it's fairly simple. It just renders that HTML of the movie cast carousel, but it also fetches the data. So this is the important and kind of very convenient thing of server components. Because they only run on the server, we can make them asynchronous functions. Then they can do asynchronous stuff on the server. The reason why you want to do that is because it reduces the amounts of back and forth between the server and the client. We don't create those waterfalls where components fetch data when they render, and then that causes another component to fetch something when that renders and all of that. The server is already close to your data sources usually, so fetching stuff on the server makes sense, usually. Cool. If we then look at the rest, all we're really doing in the classical render part is we start collecting the HTML. So we start with having the opening text, then we loop through all of our components. So this might look a little bit convoluted. Again, don't worry about the implementation detail itself, but all we're doing here is looping over each of those children. Because they're asynchronous functions, we await them, and then we render that as a string to HTML. At the end, we close our HTML, and then we send all of that through once we have it. And what that looks like is this. So this is showing the classical render, and it seems to do the job. But if we, for example, open this in a new tab, we see the big problem, the load time. Like, this is taking a while to even appear, which isn't great. It's not only the initial load, like I said in the very beginning, even if I just navigate to a new movie, so I already clicked it, it's loading, but it's not doing anything. Like the user doesn't have any visual feedback. What's actually happening? It's a pretty bad user experience. All right, so I already kind of hinted on that. We can improve that. Streaming as a concept, like I said, has been around for ages. It's basically the idea of you opening the document early on when you get the request, and then you just write as data becomes ready, and at the end you close the document. HTML is really good for that because HTML is a very forgiving language. So if you don't have any closing text, HTML, like the browser, will still interpret your stuff. So it's a perfect use case for streaming as stuff becomes available. And we're basically doing the same thing that we've done before. We still have our loop here where we render our components to a string, but instead of collecting the content and sending it all at the end, we're already starting to write immediately. So that in Express and other frameworks like that allows us to immediately open that connection and start streaming. So we also write to that stream, and at the end, we need to tell the browser that we're finished. So that's all we're doing here with the REST end. And if we now going back and open that, we see that the logo shows up immediately, which is great. And then it's all a bit mixed up. Yeah, the sections don't really make sense anymore. Now that we're streaming, we need to make sure that we're actually resolving our promises in the order that they actually meant to. So let's just quickly replace this. This is not the most efficient way to do it. There's better ways to like still run the promises in parallel, but for the sake of this demo, this works. So we just change it to a for loop. So the children will be dealt with now in the order that we feed them in. And if we now refresh this, that solves the problem. The title section is still at the top. It's a better user experience for sure, especially when you navigate around. So if you go back here, there's immediate user feedback of like the visual feedback of something is happening, but we're still looking at a mostly blank screen. We're only seeing the logo. Imagine if the logo was rendered underneath the title section, then we would still literally be like looking at a blank screen. So it's not ideal. It's better, but ideally I would want to show some form of loading state for each of these sections. And if you remember, this is exactly what suspense allowed us to do, right? It basically introduced the ability to define suspense boundaries and then define your fallback UI for those boundaries whenever asynchronous stuff happens. And on the client, that's pretty straightforward, but we can also use it on the server, that same concept. So if we look at it, this is basically still exactly the same implementation as the streaming one, but now I'm going to introduce those suspense boundaries. I'm going to wrap the title. So this is what a suspense boundary looks like. Again, with a fallback UI that I want to render whenever this isn't ready yet, or whatever is inside isn't ready yet. And I'm in full control over what I'm actually wrapping in my boundaries, which is cool. Let's wrap all of this, all of these in their own boundaries. And last one, yes, cool. So how does this actually work then? If we look at the suspense components, this is a very simplified version of what suspense components look like. This is not the implementation React has or any other framework. This is just for the sake of showing the conceptual work that these components do. It doesn't do much. Like it's very simple. It's 12 lines of code. All it's really doing is it's taking those children that we're passing into the boundary, and instead of rendering, it doesn't render them at all. It just stores them in an object, in a map based on unique identifiers. And then what it is rendering is that fallback component. And it attaches an identifier to that div, so we can later find the fallback UI based on that unique identifier. Nice CSS tip on the side. We're rendering a div here which can mess up layout stuff. So if you're rendering like a CSS grid around your suspense boundary, display contents prevents this div from messing with layout concerns. So you have your grid outside of the suspense boundary. Within your grid, you have the grid items. This will still work if we set the display to contents. Free tip on the side. But yeah, you can see basically what we're doing is we're building up this map and we're storing those potentially asynchronous children in that map. So if we look in here, or if we call that up, you see that's exactly what it's doing. It's like it's only rendering the fallbacks because we haven't told it to do anything with those children that we just store in the object. But this already looks pretty cool. So let's tell it to do something with the suspended object. After the loop where we rendered all the main children, we basically want to check, do we have anything in that suspended object? And if we do, deal with those individually, like basically do what we've done before. You render all of them to a string, and then you write that to the stream afterwards. And if we do that, we still render all the loading states, but now the content starts popping in underneath it. Because again, we're in an HTML stream. The main downside of a stream, as I described it before, it is linear. Like you can only add to the bottom of the stream because you're writing the document in one go. You cannot replace previously written content. So this is the main limitation of classical streaming. So this is close, but what we want is now to use this content to replace the loading states that we previously rendered. And to do this, we need a little bit of magic. And when I say magic, I of course mean JavaScript. There are a million different ways to actually do this. Some of them actually need less JavaScript or even no JavaScript. I've seen recent implementations with like using template slots and stuff like that. I'm going to use some JavaScript, but you'll see it's very little. But we need to do two things. For one, we can't just render the content straight as it is. We want to wrap the content in some tags, and I'll explain those in a second. So we have a template tag here, which is an HTML element that basically just tells the browser, ignore this, don't actually render this. But it allows us to still send it in the stream. And then we're rendering a custom element. And that custom element just gets the unique ID of the element of the map, the suspended map that we created in the suspense component. And all this does is allowing us to tie some custom JavaScript to that custom element. And this is now the little bit of magic part that we need. We only need this if we have suspended components, so I'm going to put it in here. And what this JavaScript basically does is we define this custom element that we call suspense content, and then we give it a connected callback. This connected callback is called whenever that element is rendered on the page. And then we can do stuff there. What we're doing here is we're selecting the previous sibling, which, because we're controlling all of this, we know it's going to be the template tag. Then we try to find the original element with a target ID, which is that suspense target ID. And then we just swap out the contents. That's it. It's like 10-ish lines of JavaScript. And with that, if we refresh the page, you see it still loads immediately with the loading states, but it now loads in the actual contents whenever they're ready in any order. And it's leading to a much nicer user experience. So the cool thing about this is all of that is server-side. Like, yeah, we're shipping a little bit of JavaScript. In this case, we're shipping it as part of the server HTML response. So if I navigate to the new movie, again, the user experience is immediate with loading states and everything. But it's also, because it's all in that HTML that we send as a stream, when I go back, the server still has the whole HTML cache. There's no loading states at all. It's just immediately there. It's all these kind of things where we can take advantage of the platform as we've had it for years now, by just doing it in these new and right ways. Like I said, we're in full control over these loading states. So instead of having suspense boundaries around each of the sections, we could have just one big boundary. Again, this really just depends on your application and how much you can actually control. Like you want to avoid layout shift, so this might be more what you want to be doing in most cases. But again, the idea is out-of-order streaming allows us to give those dynamic user experiences with dynamic loading states while still doing most of the work on the server. And that gives us kind of the golden ratio of like both the performance of server-side rendering and the dynamic and developer experience of the single-page application that we're so used to. All right, I am running out of time. So I hope this kind of showed you the conceptual, like where we're heading with web development in the future. I think this is a really exciting space to look for in the next year or two, especially when it comes to frameworks that start abstracting this out and helping us actually implement this without having to manually implement this. These are some resources if you want to look deeper, if it tickled some interest in anyone watching. I found these resources really helpful to, again, not only explain the implementation details, but the reasoning behind it, the motivations from a user experience perspective. And yeah, these are links to the slides, to the GitHub repo with the code, if anyone is interested, and to my socials. Thank you.
Excellent. Thank you very much, Julian. That was it was great actually to do that hands-on coding. I know it's always a little bit scary in doing a live event, but it was great to see it kind of just iteratively get better.
Yeah, but you could tell that I was kind of cheating out with the copy pasting there. It is scary doing it live.
I'm going to kick off with a question, but if anybody else has questions out there, please do write them in. Why would we go with streaming when we already have like optimistic rendering? We have kind of, maybe you could create a static page for each of those movies with static side generation. Why complicate things with this streaming? Because as you said, like it is a bit of effort to kind of be thinking about all the fallback states, all of the extra bits that you need to do.
Very good question. You should absolutely not do it if you don't need to. So it's basically the first principle of like, use the dumbest in quotation marks form and technology that you can for the use case that you have. If those movies don't change and static pre-rendering is an option, you should absolutely do that, because then you're just serving static files. That's always going to be faster, and like you say, it's less complex. So this is really more solving for that use case where you do have dynamic content. Think even like a user dashboard where the data has to be like it has to be fetched from the database on every request. But it's also sensitive because you have users on low-end devices and with not so good network connections and that kind of stuff. So this is really trying to solve the problems of those applications with a lot of overhead on the server potentially, where hopefully this direction can kind of solve both problems of, well, like the three problems of developer experience, user experience, and kind of performance overall. What you're mentioning of complexity is still very true, and my hope is that within the next year or two, the frameworks will kind of have evolved enough that you don't have to think about that complexity anymore. It's basically abstracted away for you, like we've done with single-page applications, where you don't do the jQuery messy spaghetti code yourself anymore. You have a framework that essentially hides that.
Excellent. Well, that's actually really interesting. And I've always thinking, somebody mentioned a point that AI won't be able to help with these new things because it's based on old paradigms. So if something new comes along, the AIs won't be very good at writing the code for it.
The irony of that is, I kind of implied it with like the diagram that I tried to show. A lot of this is inspired by old ideas. So like we learned that we went too far with single page applications, and we're now learning back like the best practice principles from like the original server-side rendering, etc. So this is actually going to be really interesting to see like how much of those old ideas can we apply while still also applying like new technologies, new ideas.
Brilliant. Well, that brings us to time. So thank you very much, Julian. I really enjoyed that.
Thanks.
Great. So up next, we have Shachar Avrahami, who's the VP of Product Strategy at EverAfter, and he'll be talking about why products should own your customers' business objectives. So I would like to welcome Shachar to the stage. Over to you, Shachar.
Hello, and hey everyone. Thank you for having me here today. So as mentioned, I'm going to speak about why product or product departments should own, at least partly, your customer business objective. Just a little bit about myself. So I started my tech journey in the customer success domain, specifically in the customer success operations and revenue operations domain. I work with customer-facing teams to make them more efficient and more organized. In the past 5 years, I'm the VP of Product and Strategy at EverAfter. In my personal life, I have a really, really cute cat that I'm sure that you're smiling when you see this picture, but unfortunately, I'm not able to see that. One slide about EverAfter. So we are a B2B customer interface platform, and we allow B2B organizations to productize a whole bunch of different customer programs to make sure that customers achieve their desired outcome with your solution. So let's start. And I would like to start with an analogy that I had when I saw the movie Inside Out. I don't know how many of you actually saw that, but Inside Out is a really, really great movie by Pixar that takes us to what happens inside the main character's mind. And they have like a lot of different emotions, and each emotion has a different role. And I saw this movie a few months ago with my nephews. I promised them that I will do like a movie day with them, and I forgot, and then my sister reminded me. So we watched this movie, and when I saw that, it actually it sparked some ideas on how we could leverage some of the things that they show in this movie to what we do when we build really, really great products and workflows for our customer. So I'm big on AI, so I definitely leverage a lot of AI pictures inside my presentation. So I would like to first introduce you to Emma. And let's say that Emma is a made-up character, is a marketing operations manager at a 500 people company. She's a super top performer in her company. And now her manager would like to introduce her to a new technology that he wants her to implement. And let's say that this technology, it's a made-up company called Funnel Pro. And Funnel Pro helps marketing team solves a lot of their challenges. So because Funnel Pro is a platform, Emma realizes that the platform has a lot to offer, which makes it very difficult for her to start. So when she starts, I'm sure that you're all familiar, she potentially got an email with a lot of different resources that she should leverage, she should read, she should watch. She got this automated email, welcome to Funnel Pro, here are your 20 different resources. And it was a bit overwhelming for her. And the struggle is real, because how you could even start when you have so many things to do on your plate? How could you know what would be the best path for you to succeed? So she tried to speak with someone. She opened a support chat, and she got a reply from a CSM, customer success manager, that was able to meet her only 5 days later. And with that, Emma was a bit stuck. We're going to fix the situation that Emma witnessed towards the end of this slide. But I'm sure that many of you that got introduced to new technology might experience the same sense of being a bit overwhelmed. And as I mentioned, I come from a customer success background. I did the transition to product, and I'm building products in order to solve a lot of the customer success challenges. And I don't know if you're familiar, but customer success is one of the most growing departments in the last decade. And you could see that in number of new positions in this area, and the part of customer success from all of your company's headcount. So while this is a fact, I do want to zoom in and maybe understand why the demand for customer success is high. And based on what I know, this is the number one reason that customers need customer success manager. And I'm going to connect it to product in a moment, because it starts actually with our products. The products that we built became more complex. We no longer offer point solution. We have platforms. It's no longer one size fit all. We try to serve different personas across different industries. And therefore, we have different goals to solve for. We have different integrations. We have different workflows. We build much more flexible platforms, which means that we have much more configurations that our audience need to learn. And that creates a challenge. And not only it creates a challenge, our customers, and I don't know how many of you could agree, also became more complicated, because now they have more stakeholders that they need to prove value with the product that they chose. They have a lot of legacy systems that they need to integrate with the new tech that they just purchased. They already have their own workflows. Now they have a lot of regulations that they need to follow, GDPR, security permissions, and a lot of different challenges that they need, which makes every implementation and any work with an existing or with a new platform a bit more challenging. And when we combine the complexity that we build when we build our sophisticated products with the complexity by nature of our customer organization, it's very difficult to succeed without doing anything in particular. And basically, in order for our customers to succeed, we need to come up with a personalization layer that will help to guide customers and create for each customer their own personalized path to success. And when we build this personalization layer, there's a lot of different factors that we need to take into consideration, from the products that our customer purchased to the roles of the people that we work with. Are they like a big customer? Is it a small customer? Which tech stack they need to integrate? A lot of different parameters that basically means that every customer has a different path for success. And we, as an organization, and in a moment I will speak about our role in product for that, we really need to create this personalization layer for our customers. And throughout the years, the personalization layer that the industry came up with would be the customer success manager. Customer success manager is the ultimate personalization layer for your customers. Because if we zoom into the mind of a top CSM, to a top customer success manager, basically, they create an algorithm with a lot of different different signals that they know about their customer, because they know the customer the best. They know their goals, they know how they use the product, they know the industry, they know the segment, they know all of the changes with the stakeholders, they know the health score. So they have a lot of different signals that they capture throughout the work with their customers. And top CSM basically inject all of those variables and signals into like an algorithm. Obviously, it's not a real algorithm, but their mind acts as their algorithm. They try to cross-analyze all of those signals. They try to really understand what is urgent, what is impactful. And basically, it's a good or a great customer success manager will know how to curate for the customer, with all of the things that I just mentioned, what is the most valuable action that my customers need to take? And this is basically how they are able to drive success and to create this layer of personalization to the customer. So it could be that they will tell the customer, you need to use this feature, and this is how you need to watch this recording or this video, and this you should, they could build together with them a success plan. And to be honest, when the customer success manager, they provide the relevant and personalized guidance and recommendations to the customer, I would argue that in a different world or in a different mindset, that should be our role in product. because our responsibility is to make sure that our customers have a really, really good path for success. So I called the title of my presentation was that why product should own your customer business objectives. So I want to give you some examples what happens when we don't own our customer outcomes. So in general, when we have large organizations that purchase our software, our platforms, our solution, they have specific outcomes that they expect to have with our platform. And as our platforms mature, we can assume what would be those outcomes. However, it started to be a reality that the person or the department that owns the customer outcomes would be the customer success, and I'm here to challenge it, because I think that we have in our own product departments, we have a lot to gain and a lot to lose if we don't think about how to own the customer outcomes. And let's start to talk about that. So first of all, when we don't own our customer outcomes, the feedback loop that is so valuable for us in order to make sure that we develop the right stuff breaks, because we need to rely on other departments in order to provide us the feedback that we don't really hear firsthand, and we don't really witness the challenges that our customer success managers face when they try to work with customers towards right outcomes. And this leads that we might build the wrong things, because we don't build the things that would move the needle towards achieving customer outcomes. And when we optimize for adoption of specific features, when time spent in our app, we might forget that even if our customers have high usage, it doesn't mean that they will necessarily retain or stay with us. So there is a chance of higher churn rate when our customers don't meet their outcomes. And I think that this is a challenge that we should have, that we have to face, and we have to see how we can optimize and help the organization solve. Which leads that customer success and sales have to fill the gap for us, because we build a super sophisticated platform that in order to use that, someone needs to really digest it, and someone needs to create a path for our customers. So they fill the gap for us, which is not optimal because they have other priorities to focus on. And I think that this is something that it leads to that we become a service function and not a strategy function, because we will rely on sales and we rely on customer success to tell us what our customers need, so we will know what to develop. And I think that now, especially in 2025, with the rise of AI, we suddenly have a choice to become closer to really helping our customers to achieve their outcomes. So if until this point, in order to create this personalization layer, we relied on customer success managers, now we have a real chance, because now in today's world, in the new world, we have the ability to develop this personalization layer that will rely more on technology and less on our customer success managers. And if we do it properly, then this technology, and it's not a specific tool or it's not a specific platform, it's like the thinking behind that, leveraging technology to help us to curate the next best action to our customers to make them more autonomous so they could achieve their business desired outcomes. And for that, I would like to introduce you to a concept that is called the Autonomous Customer Org. And the Autonomous Customer Org is a concept that we came up with that basically, when we are able to execute or to roll out this Autonomous Customer Org, our customers and us and organizations have a lot to gain. So basically, the Autonomous Customer Org, which I believe we should own in the way that we build our product. Basically, it's a system that pushes customers towards never-ending progress. We think about elements and we design a system that will fit to each customer an adaptive path in-app inside our product that will guide them based on their input, based on the signals. And I'm not talking about tooltips or like in-app tools. I'm talking about an actual system that will be a part of our product, that will listen to the customer, that will ask customers what they need in order to succeed, and will be able to focus the customer on the actions with the highest impact based on everything that we know about customers. This autonomous customer org system will speak to the customer in their own language. It will know how they like to learn, how they like to do stuff, and will adapt based on that. It will focuses the customer on getting things done, because when our customers do more stuff, it gets them a bit closer to achieving their own business outcome. However, it will know to escalate to the relevant team members when needed. So, in order to build, and I'm going to share like a framework on how I believe we can start building this autonomous customer org, and after that, I'm going to show you 4 live examples on how you could build it tomorrow. But the engine that we need in order to create this autonomous customer org or this autonomous journey engine contains 4 parts. The first part would be the different inputs that we need to start gathering in order to make decisions. So I'm sure that many of you track a lot of different product usage. So basically, we need to create for each customer a data layer that takes into consideration a lot of different signals, product usage. We need to capture the customer goals in a way that would make sense. We need to identify a lot of what is the customer lifecycle stage, who we work with, because 2 different personas under the same organization might have different goals, so we might need to help them become autonomous in a different way. Then, I don't know how many of you are familiar with the concept of next best action, but the next best action is a super, super critical part in order to create customers, to make customers more autonomous. This is the big brain of the engine. It's a decision layer that takes all of the inputs and calculates for each customer what is the single step that they need to do in order to maximize their ability to maximize their desired outcomes. We borrowed this model from marketing and from sales. There's a lot of studies that says that when marketing people incorporate next best action as a part of their cart on the e-commerce website, so it increases the cart, and a lot of really, really good things that marketing team can benefit from. So we can actually borrow that when we build and design products and incorporate as a part of our product this next best action mechanism that will identify what the customer needs to do in a very autonomous way. Then we also need to focus on how we surface this next best action to the customer. So we need to tell them what to do, why they need to do that, because when we give them a good reason, it increases the chances of them to actually do that. We also need to give them clear instructions, embedded instructions on how to do that. And we also need to surface the action in a designated interface. So if you will have even like inside your product, like an area for next best action that customers can always go back and see what is the most relevant recommendations for them and how we actually push them towards done. The last part would be a feedback loop where the actual system learns from failures, learn from success of this particular customer and for other customers with similar next best action. Basically, we need to learn what went well, which actions got the most completion, and all of that. So I'm going back to Emma, and I would like to rewrite Emma's story. And as a reminder, Emma just got introduced to Funnel Pro. But inside Funnel Pro, and because the Funnel Pro product team really wants to make Emma autonomous, so they created those type of creatures inside Funnel Pro. And the purpose of the creatures would be to analyze anything that Emma needs. They will incorporate and they will learn what Emma needs, what are her challenges, what she needs to focus on. They will blend it all together. And every time they will extract a single next best action for Emma. When the next best action is ready, they will deliver it to her in a super engaging way. they will guide her until the action is done. And they always work on on calculating the next best action for Emma, and they deliver this next best action in a very engaging way. So if you're here together with me until this point, and you're curious on how to get started the journey to make our customers a bit more autonomous, I would like to offer you 4 different options, and then another asset that will help you if you would like to see like a full list of 15, I think, recommendations. So I think that the most important thing for me, if you only need to choose one thing, would be to build an NBA, or next best action mechanism. And luckily today with AI, you could actually build an AI agent that will read for each customer all of the relevant data points and will calculate the next best action for each customer. So we actually use our platform for that. So we have like an agent builder that we could generate specific next best action, or we could actually train different agents on what we want. And here it's pretty small, but I actually created a next best action agent. I pulled a lot of different data points on each customer, and every day this agent calculates based on a lot of different data what the customer needs to do. So it is able to curate for a customer the next best action, but also I chose, because I really like visuals, so I actually chose that every day the next best action will be presented as a pop-up to the customer, kind of like a recommendation of Netflix. So every day a new image will be generated with AI based on the agent that I've built. With that, our customers have a really, really clear way or a clear path of how they could actually progress in a meaningful way. I don't know how many of you are familiar with the concept of a success plan. Success plan, this is something that a lot of customer success managers do manually together with their customers, but we could actually build an autonomous success plan system. And I'm going to show you an example that Okta actually was able to implement for their thousands of non-managed customers. And their framework, and this is embedded as a part of the Okta experience, takes customer on 4 different steps. The first step would be to collect customer goals based on what the product team knows that customers are mostly interested in solving with Okta. Based on that, and based on a lot of data of their customer setup and configurations and product configurations, they calculate for each customer a maturity score. Right after that, they curate a list of personalized recommendations that the customer should take in order to achieve their actual desired business objectives. So it knows what the customer did or didn't do, and it shows only the things that the customer didn't do and would help them to achieve their outcomes. And once customer marks 80% or takes 80% of the recommendation, they actually reveal advanced steps. And the process here, as I mentioned, is a process that could be manually by the customer success manager, but many of your customers and for Okta customers, they don't have a dedicated customer success manager. So with that, they are able to really build and push customers to the action in a very self-service approach. Another approach, and here I'm actually going to show you something live from our product. So this is, for example, our homepage of that our customers see. When they click this little EverAfter sign, they get here something that we've built for them and we embedded for each customer. We give them like a benchmark and a score on how they could leverage more capabilities from our platform. So for example, each customer could see what is their score, and this is interactive, what is their score under journeys, which is a module of us. They could click here. They see here a deeper level of benchmarking. And based on whatever is not green, they see clear recommendations of what they need to do in order to improve their score. And this is being calculated from our own product data on our customers on a daily basis. So every day we will calculate and we will show them what they need to do. And we actually invite them to collaborate with us. We bring them the resources. They are able to track the different use cases that they would like. And we saw that once we did that, it gives me on every new feature that we roll out or any new model that we roll out, the ability to really push it and give some kind of like a score and guidance to our customers. The last thing that I will share would be that you could also ask customers in-app when is good for them to act, and you could actually create an agent that will take whenever they like to learn. So for example, my customers are free at Friday at 2 p.m. So every Friday, automatically, I will block something on my customer calendar with the clear recommendations of what they need to do in this time slot. I know that this was a lot. I did create it here, and you could scan this QR, a guide on how to build an autonomous customer org. It has, I think, around 15 recommendations on how to get started. If you'd like to continue the conversation, so find me on LinkedIn. I'm really happy to have conversations and help product departments start the journey. And I think that the most important for me to end my session with is that I know that it sounds like it's a customer success mission, but I really think that in order to be strategic and in order to really help to build the right product, this is something that we should try to have more ownership on. So thank you. And if you have any questions, I'm happy to answer.
Excellent. Thank you very much, Shachar. Like I love the concept of personalization to recommendation, because you try your best to build a one platform fits all, and it can be very difficult depending on the needs of different customers.
Yeah, and I mean it's a good challenge, right? I mean, we build robust platforms, but now we need to really provide a clear path for each customer to navigate between this complex system.
Great. We have time probably for one, maybe two questions. So I'll jump in with the question that's kind of the bit that I found the most difficult when I've implemented systems like this, and it's gathering the data around the org. So we have that data, as you said, there's that wealth of data, but in my experience, it's often scattered around an organization. It's not in one nice little neat system that I can just extract it from. So yeah. Do you have any recommendations or advice for people who might be looking to start on this journey about how they can start pulling that data together?
So there is a behavioral data, but there is also like input that we can simply ask customers. So a lot of information actually would sit in your CRM. So what we did, we actually connected some of the fields that we have from the CRM, and we put it here in front of the customer. And then we ask the customer, hey, tell us, what are your goals? Who should we work on to achieve those goals? And by actually letting customers to provide this goal, so first of all, we are able to push it back to the CRM, so everyone in the organization could benefit from this data point, and we give the customer the ability to really tell us what's on their plate. So just asking the customer, and if it's a part of of like a very engaging experience, like in-app, so they don't need to go anywhere else. So this would be a good way to start. If you have a system that could track, product, we use Full Story, for example, so we could actually track some of our product usage, and also we sync to our we use BigQuery, but we actually surface there when customers activated specific integrations, how many programs they have with us. So I think that we can always start with something, even if it's not like super holistic, but start with something as customers and track that over time.
Brilliant. That's great advice. I love the mixing of qualitative and the quantitative kind of data there between your different systems. That actually brings us to time. So I just want to thank you once again, Shachar, for sharing, and I hope everyone out there enjoyed it as much as I did.
Thank you. Have a good one. Bye-bye.
Right. So that brings us to an end for today, but I hope you enjoyed the talks. And if you did enjoy the concept of what we're trying to achieve at UXDX, which is bring together product, UX, design, and dev, so that you can build a more holistic and better performing product together, then please do consider joining us at one of our main conferences that we host in the USA coming up next May, and in Berlin next May as well. But if not, I just want to thank once again both of our speakers this evening for sharing their insights and their stories with you. And I look forward to seeing you at the next UXDX Online. Thank you very much.